Morning class ninth class. All of you welcome in my class. बेटा आज हम डीजी क्लास कर रहे हैं साइंस की स्ट्रक्चर ऑफ द एटम. अच्छा बेटे, स्ट्रक्चर ऑफ द एटम. आई होप यू आर ऑल बी अटेंडिंग द क्लास. ओके बच्चा, लेट्स सी स्ट्रक्चर ऑफ द एटम. थॉमसन्स मॉडल ऑफ एन एटम. अब हम थॉमसन्स मॉडल ऑफ एन एटम के बारे में देखते हैं. क्या बोला था थॉमसन्स मॉडल ऑफ एन एटम में? लेट्स सी बेटा.
When we rub two materials together, a charge is created. The charged material can attract the other material. Where does this charge originate? What are these charged particles? Are they inside the atom or outside? If they are inside, how many types of charged particles are there? Are they tinier than atoms? Does this mean an atom is divisible? Let's explore the atom from John Dalton's model. According to Dalton, the atom is indivisible and indestructible. Goldstein discovered positively charged radiation in gas discharge and called these rays canal rays. This confirmed the presence of positively charged particles. In 1900, J. Thompson discovered the existence of negatively charged particles. Dalton's atomic model failed after the discovery of subatomic particles such as proton, electron, and neutron.
Okay beta, negatively charged particles are easily peeled off from an atom and positively charged particles are not. What do you interfere? इससे आपको क्या पता चलता है? The negatively charged particles are present in the inner core of an atom. The positively charged particles are present in the inner core of an atom. The positively charged particles are present in the exterior of an atom, or negatively charged particles are present in the exterior of an atom. तो ये कुछ पॉइंट्स डी पॉइंट्स हैं. तो आप देखिए क्या बताया गया है इसमें. ये पॉइंट्स दिए हैं तो देखिए बेटा. The positively charged particles are present in the inner core of an atom. The inner core में पाए जाते हैं. Let's see. Thompson's model of an atom.
An atom is a positively charged sphere, and electrons are embedded in it. The atom is neutral, since it has an equal number of positive and negative charges. We can visualize J. Thompson's atomic model by comparing with the pudding cake and watermelon. The negatively charged electrons are embedded in the positive sphere, like dry fruits in a pudding cake. Look at this watermelon being cut into two halves. Electrons are like the black seeds embedded, and the positively charged mass is similar to the red edible portion of the watermelon. Rutherford conducted a scattering experiment on gold foil with alpha particles containing positive charges. Thompson's model failed to explain the result of this experiment. Rutherford suggested that protons and neutrons are present in the nucleus, that is, at the center of the atom.
Okay बेटा, इन्होंने ये डिस्कवर करा था जे थॉमसन ने एटॉमिक मॉडल में कि बीच में जो एटम होता है उसमें पॉजिटिव और नेगेटिवली चार्ज प्रेजेंट होते हैं। बेटा देखिए, charges of particles.
Protons are positively charged subatomic particles. Let's represent the proton by the letter P. They are centrally located in the atom. Electrons are negatively charged subatomic particles. Let's represent electron by the letter E. They are much lighter than protons. They are present in the exterior portion of the atom. Some subatomic particles are neither positive nor negative. Such neutral particles are called neutrons. They are present along with protons in the inner core of the atom.
एटम डल्टन मॉडल है, चार्ज पार्टिकल है, न्यूट्रॉन प्रोटॉन पॉजिटिव और नेगेटिव है, इक्वल नंबर होते हैं उसमें, और फेलियर हो गए सब एटॉमिक पार्टिकल्स आने से। ये डल्टन मॉडल थ्योरी फेल हो गई बच्चा। ओके बेटे, एटम्स डल्टन वाली है, डल्टन एटॉमिक थ्योरी फेल हो गई कब? जब सब एटॉमिक पार्टिकल्स का डिस्कवर हुआ। अब है रदरफोर्ड। अब हम करते हैं बोर मॉडल बेटा। लेट्स सी बोर मॉडल एंड इट्स वैलेंसीज, जो आपके काम के हैं आनी है, रदरफोर्ड एंड बोर मॉडल ऑफ एन एटम एंड वैलेंसीज।
Here is the celebrated electron stunt. A pair of electrons shows their whirling dance inside a globe of death. Do they remind you of something in a circus? Yes, the motorists riding on the wall of death. Look at these daredevil riders revolving at a terrific speed inside the globe. Were the motorists thrown out of the globe? No. Did the motorists collide with each other at the center? No. Just like motorcyclists on the wall of death, electrons also revolve in a stationary orbit around the nucleus in an atom. They do not jump out of orbit without absorbing energy. Niels Bohr explained this phenomenon of electrons in his model of an atom. Electrons revolve around the nucleus in discrete orbits. These orbits are called energy levels or shells. These orbits are represented by the letters K, L, M, N, or the numbers n equals 1, 2, 3, 4. Electrons do not radiate energy when they revolve in discrete orbits. Electrons radiate energy when they jump from a higher energy level to a lower energy level. For example, when an electron jumps from energy level 5 to level 3, it loses energy by emitting radiation. Similarly, it absorbs energy to jump from a lower energy level to a higher energy level. Bohr studied the spectra of energy in hydrogen when the electrons jump from different higher to different lower energy levels. These were named the Lyman, Balmer, Paschen, Brackett, and Pfund series of hydrogen spectrum. Bohr was able to calculate the amount of energy transferred as well.
Okay, बच्चा, total energy E2 minus E1. इनमें बताइए बेटा जो हिडन है जरा देखिए. Let's see. Orbit, shell, scatera, electron jump energy level.
Electrons are distributed in different orbits. The maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number. The shells are filled in a stepwise manner. The first shell, the K shell, can accommodate 2 electrons. The L shell can have 8 electrons. The maximum number of electrons that can be accommodated in the outermost orbit is 8. The hydrogen atom has 1 electron in the K shell. The helium atom has 2 electrons in the K shell. Lithium has 2 electrons in the K shell and 1 electron in the L shell. We can represent these electrons as 2, 1. Beryllium has the atomic number 4 and it has the electronic arrangement as 2, 2. That is, 2 electrons revolve in the K shell and 2 electrons in the L shell. Boron has 2 electrons in the K shell and 3 in the L shell. Carbon has the electronic arrangement 2, 4, representing 2 electrons in the K shell and 4 in the L shell. Similarly, nitrogen has the electronic arrangement 2, 5, indicating 2 electrons in the K shell and 5 electrons in the L shell. Oxygen has the electronic arrangement 2, 6. Fluorine has 2, 7. Neon has 2, 8. Sodium has 2, 8, 1. And magnesium has 2, 8, 2. Aluminium has the atomic number 13. It has the electronic arrangement 2, 8, 3. Indicating 3 electrons in the M shell. Silicon has the electronic arrangement 2, 8, 4. Phosphorus has 2, 8, 5. Sulfur has 2, 8, 6. Chlorine has 2, 8, 7. And argon has 2, 8, 8. Argon has 8 electrons in its outermost shell.
The maximum number of electrons present in a shell is given by the formula. कौन सा फार्मूला गिवन होता है मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स के लिए? बेटा हम आपको बताया था मैंने क्लास में भी और डीजी क्लास में भी अभी बताया आपको कि जो फार्मूला है वो है 2 इंटू एन की पावर 2 से इसको करा जाता है. 2 इंटू एन की पावर 2. एन तो नंबर ऑफ शेल्स होते हैं बच्चा. ओके, तो लेट्स सी. 2 इंटू एन की पावर 2. ओके, वैलेंसी, अब हम करते हैं वैलेंसी बेटा।
Valency is defined as the combining capacity of an element. It is the number of electrons lost, gained, or shared to attain an octet in the outermost shell. When are the electrons tempted to jump out of their orbit? When the electron in the outermost shell is influenced by the approach of another element, electron transfer can take place. It can lead to the sharing of electrons with the other element or the transferring of electrons from one element to the other. For example, sodium loses one electron in the vicinity of chlorine. In turn, chlorine gains one electron from the approach of sodium. Thus, they form a better stable compound, sodium chloride. Valency is 0 for an element when it contains 8 electrons in the outermost shell. It implies that the element is inert. For example, argon. Valency is the tendency to attain the fully filled outermost shell, that is, 8 electrons. It is called an octet. Just as countries align themselves for a better stability, elements too can align with other elements optimally with the exchange of electrons. When an element contains one electron in the outermost shell, its valency is 1. Example: hydrogen, lithium, sodium. In the case of chlorine, the outermost shell contains 7 electrons. An octet is easily achieved by gaining 1 electron instead of losing 7 electrons. Hence, the valency is 1. Let's find out the valency of oxygen, whose atomic number is 8. To find its valency, write down the electronic arrangement of oxygen. It is 2, 6. 2 electrons are required to attain the octet, that is 8. Hence, oxygen's valency is 2.
ओके बेटा, आउटर मोस्ट शेल में अगर 1, 2, 3 इलेक्ट्रॉन्स होते हैं तो वो शेयर इजीली कर लेता है, वो इजीली इलेक्ट्रॉन्स दे देता है और शेयर होके वो क्या हो जाता है, उसकी इलेक्ट्रॉनिक कॉन्फ़िगरेशन मीन्स आउटर मोस्ट शेल वो कम्प्लीटली फील्ड हो जाता है, स्टेबल हो जाता है। ओके बच्चा, लेट्स सी, जिसका नंबर एटॉमिक नंबर 14 होगा तो वैलेंसी क्या होगी, लेट्स सी। टू 8 4, तो वैलेंसी है 8 - 4 लास्ट शेल, दैट इज 4। ओके बेटा, बोर मॉडल और वैलेंसी के बारे में बताया था मैंने आपको। अब देखिए जरा, बोर मॉडल शेल्स में डिवाइड होते हैं, के एल एम शेल में, के शेल में 1 इलेक्ट्रॉन्स, ये फर्स्ट शेल है, सेकंड शेल है, थर्ड शेल है, सबसे ज़्यादा इसमें 2, के शेल में बेटा 2, 8, 8। ओके, मोर स्टेबल होते हैं अगर मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स इसमें होंगे तो, और एनर्जी एमिट कर लेती है, ऑब्जर्व भी कर सकती हैं ये। ओके बच्चे, वैलेंसी से गेन और लॉस हो सकते हैं, शेड हो सकते हैं, डिनोट कर सकते हैं, रिसीव भी कर सकते हैं वैलेंसी से इलेक्ट्रॉन्स। आउटर मोस्ट शेल में 8 इलेक्ट्रॉन्स होने चाहिए। ओके बेटा, लॉस, गेन और शेयर कर सकते हैं, आउटर मोस्ट शेल में 8 इलेक्ट्रॉन्स होने चाहिए। ओके बच्चा, इसी के साथ ही हमारी ये क्लास यहाँ पर अब आज होती है। आपको समझ में आ गया होगा, बी क्लियरली समझ में आ गया होगा बोर मॉडल से इलेक्ट्रॉन्स के बारे में और बोर मॉडल और उसके बाद उसकी वैलेंसीज के बारे में। ओके बच्चा, So be careful, stay at home. Okay बच्चे, bye.